Today we're going to be talking about periodic trends. As we learned, the periodic table is an arrangement of elements in increase in atomic number and grouped by similar properties. With that in mind, the periodic table contains trends of properties. And there are three important trends the periodic table has. There are a lot more trends that it has, but we're only going to be focusing on three. We have atomic radii, radius, ionization energy, and electronegativity. First one we're going to talk about is our atomic radii. The atomic radii is 1/2 the distance between the nucleus and the identical atom that are bonded together. Essentially, it's how big an atom is. And the atomic radii increases as we go down a group because more orbitals are being formed. We know that when we do Bohr models. A Bohr model that has a lot more orbitals than another one means that model, that drawing, is going to be a lot bigger than the other one. It also increases as we go right to left of a period because less electrons are being added to the outermost orbital, which causes a weaker pull to the nucleus. We know the nucleus, the center of the atom, has protons and neutrons. Protons have positive charges, but neutrons don't, so we have a positive charge center. Our electrons are orbiting around our nucleus, and our electrons have negative charges. Opposites attract. In chemistry, golden rule of chemistry, opposites attract. Positive and negatives want to come together, meaning the negative electrons want to come to our positive protons, our positive center, which causes an attraction, a pull. If there are less electrons, that pull is going to be weaker, meaning they're going to be more far apart from each other, which causes the atom to become bigger. Alright, so looking at that periodic table for atomic radii, we just said the atomic radii increases as we go down a group and as we go right to left of a period. So let's go ahead and do some practice problems and circle to the pair of atoms that has a higher atomic radii. Our first problem, we are comparing lithium and potassium. Lithium and potassium are in the same group, and since the atomic radii increases as we go down, the element that's further down in the group is going to be higher. So potassium will be higher atomic radii and lithium will be a lower atomic radii. Now looking at calcium and nickel, these two are in the same period, and we know the atomic radii increases going left. Therefore, calcium is going to be higher than nickel. Now we have OS and gold, again in the same period, increasing going right to left. OS is further left, so it has higher, and gold has lower. And finally, we have aluminum and gallium. They're in the same group. Increases as we go down. Gallium's further down, so it's higher atomic radii than aluminum. Next, we're going to talk about ionization energy. Ionization energy is the energy required to remove one electron from a neutral atom of an element. So pretty much needs some sort of power, some sort of force to remove that electron off the orbital, and that is ionization energy. And it increases as we go up a group because there's less orbitals, which means the electrons are closer to the nucleus, makes it harder to remove. Again, that attraction between our electrons and our protons in the middle. If those electrons are actually closer to the nucleus because there's not that many orbitals, that attraction, that force, that pull between them is going to be super strong. So we need more energy to remove it. That's why that ionization energy is going to be higher. It also increases going left to right of a period because there are more electrons in the outermost orbital, which then has a stronger attraction to that nucleus. Makes it harder to remove. Meaning, if we have more of those negative charges, that attraction, that pull is going to be a lot stronger to the nucleus. So therefore, we need a lot more energy to remove that electron. Alright, so looking at the ionization energy trend for the periodic table, we just said ionization energy increases as we go up a group and as we go left to right of a period. So now let's go ahead and figure out which element in each pair has a higher ionization energy. First, we have calcium and vanadium. These two are in the same period. We know ionization increases going to the right. Vanadium's further right, so that's going to be higher ionization versus potassium. Now we have beryllium and barium. These two are in the same group. ionization increases going up, beryllium's higher up, so beryllium has a higher atomic ionization energy versus barium. Now we have oxygen and lithium. We know ionization energy increases to the right. Oxygen's farther right, so has a higher ionization energy than lithium. And finally, we have boron and gallium. Same group, increases going up. Boron's higher up, so boron has a higher ionization energy than gallium. And lastly, we're going to talk about electronegativity. Electronegativity is a measure of the ability of an atom in a chemical compound to attract electrons from another atom in a compound. Essentially, electronegativity and ionization are pretty much the same. The only difference is now we have a compound pulling that electron. So it's still the energy, but it's the energy that the compound has to remove that electron. Since they're both talking about energies to remove electrons, the trend and the reason why that trend is going to be the exact same. So it increases as we go up a group for the same reason. Less orbitals, which means electrons are closer to the nucleus, makes it harder to remove. It also increases as you go left to right of a period because more electrons in the outermost orbital, which then has a stronger attraction to the nucleus, makes it harder to remove. And like I just said before, that electronegativity and ionization are essentially the same, causing the trend to be the same. So just like ionization energy, electronegativity increases going up a group and left to right of a period. So again, we're going to go and do some practice problems, and we're going to circle the element in each pair that has a higher electronegativity. First pair we have is fluorine and chlorine, same group, increases going up, so fluorine has a higher electronegativity than chlorine. Now we have calcium and nitrogen, same period, increases going right, so nitrogen has a higher electronegativity than carbon. Then we have calcium and krypton, is same period, increases going right, so krypton has a higher electronegativity than calcium. And then finally, we have chromium and tungsten, same group, increases going up. So chromium's going to have higher electronegativity than tungsten. And that's it. Thanks, guys.